Good day, my audience. Now, today we are still looking at systems of linear equation. Now, I'm going to apply this system of linear equation to linear combination of vectors. Linear combination of vectors. Now, we are going to write the vector v 4, 9, 19 as a linear combination of these three vectors right now. Okay, so we are going to look at this in this perspective. Okay, now V is a linear combination of u1, u2, u3 if we have it as x u1 plus y u2 plus z u3. And by the way, you are going to write these vectors as column vectors. We're going to write them right now as column what? Vectors. So we have, as column vectors, we have 4, 9, 19. And we have our x. We have u1 is what? 1 minus 2, 3 plus y. Our u2 is what? 3 minus 7, 10. And our z is 2. Okay, our z is there. Then our u3 is 2, 1, and 9. And then when we look at this, we are going to have, multiplying this to this, you have x minus 2x, you have 3x. Okay? Now, plus 3y. This plus this is plus y times minus 7 is minus 7y. You have plus 10y plus z times 2, you have plus 2z. You have plus z. You have plus 9z. This one is equal to 4. Okay, this second one is equal to 9. And finally, the third one is equal to what? 19. Now, we are going to row reduce this equation to echelon form to solve the system. Now, you can also use the augmented matrix method, any method you want to use. Now, I'm going to use the Gaussian elimination method. Using the Gaussian elimination method to evaluate the first one, let's take the operation. Let's take the operations 2 arrow 1 plus arrow 2 will give us arrow 2. Okay, let's take it there. 2 arrow 1 is what? You have 2x plus 6y plus 4z is equal to 8. I'm trying to eliminate x from the second and the third equation. That's what I'm doing exactly. Now, arrow 2 is minus 2x minus 7y plus z is equal to 9. This will give us 0. Here you have minus y. Here you have plus 5z is equal to 17. This is 5z equals to 17. Also, if we look at the second, okay, what I've just done, this is equation 1. This is your arrow 1, this is your arrow 2, this is your arrow 3. Okay, if I eliminate x from here, I'm going to have minus 3 arrow 1 plus arrow 3 will give me arrow 3. Okay, that's the second equation. We have minus 3x minus 9y minus 6z is equals to minus 12. Stack it as against arrow 3. Arrow 3 is 3x plus 10y plus 9z is equals to 19. If you add, this is going to give us 0. This and this will give us y. Okay, this and this give us y. And then this and this we add up to give me plus give me plus 3z is equals to what? 7. Now the system becomes, I'm going to clean here, the new system becomes x plus 3y plus 2z is equals to 4. And then the second row becomes minus y plus 5z is equals to 17. That is this one. And the third one becomes y plus 3z is equals to 7. Now, if I eliminate y from the third equation, because this one is a leading variable, this is also a leading variable. If I eliminate this one, I'm going to have r2 plus r3. This plus this will give will give me 8z is equals to 24. Okay, so we are going to have the new system. The final system is x plus 3y plus 2z is equals to 4 minus y plus 5z is equals to 17. And we have 8z in place of r3. We have 8z is equals to what? 24. So this is the new r1, r2, r3. Okay, there's something that is happening here. Now, in this echelon form, we have three variables x, y, z, in 3 equations. So we can now solve by back substitution. From here, we have 8z is equals to 24. By back substitution, we have z is equals to 3. Okay, when we substitute here, we have minus y plus 5 times 3 is equals to 17. Minus y is equals to 17 minus 15. Minus y is equals to 2. Therefore, y is equals to minus 2. Okay, also when I add here, I'm going to clean that side. I'm cleaning here now. I'm cleaning here. To solve up, we have x. I'm solving this equation, x plus 3. Our y is what? Minus 2 plus 2 bracket z is what? 3 is equals to 4. Okay? We have x minus 6 plus 6 is equals to 4. Therefore, x is equals to what? 4. Hence, we can write v as a linear combination of, we have x u1 plus y u2 plus z u3. So the vector v becomes, our x is 4 u1, our y is what? Minus 2. So we have minus 2 u2, and our z is 3 plus what? 3u what? 3. So we can write v as a linear combination of the 3 sets of vectors u1, u2, and u3.